On August 25, 2012, a 35-year-old spacecraft crossed a line nobody could see, and the celebration started almost immediately. Humanity had reached interstellar space. First object ever. A triumph. Read the data, and the triumph gets quieter. In the space of a day, the plasma around Voyager 1 got roughly 40 times denser. The particles our sun throws outward, the ones that had surrounded that spacecraft its entire life, dropped to almost nothing. And the galaxy's radiation, the high-energy stuff that had been held back for 35 years, stepped up and stayed up. Then, the strangest part. The magnetic field didn't turn. Every model said it should. It didn't. Voyager didn't arrive somewhere. It fell out of something. Something that had been quietly shielding it since 1977. And what it fell out of is the only reason you have never had to think about any of this. Stay with me. Let me give you the number first, because the number is where most people stop paying attention, and it is exactly where you should start. When Voyager 1 crossed that boundary, it was about 122 astronomical units from the Sun. Roughly 18 billion kilometers, 11 billion miles. Numbers like that go numb the moment you hear them, so translate it into time instead, because out there, time is the more honest unit. A command leaving Earth took about 17 hours to arrive. You send an instruction at breakfast, and it lands the next morning. You ask a question, and the answer reaches you the day after that. That is not distance. That is isolation with a schedule attached. Nobody is going out there. Nothing is coming back. Whatever Voyager 1 measured, it measured alone, and we found out about it a day late, every time. The headlines wrote themselves: humanity's first interstellar spacecraft. The farthest object we have ever made. A golden record carrying whale song and Bach into the dark. All of it true. All of it the softest possible reading of what actually happened. Here is what the instruments said. Voyager 1 has an antenna that can feel the vibration of plasma. And plasma vibrates at a frequency set by how dense it is. Inside the Sun's territory, the gas around the spacecraft was thin almost past belief. Somewhere near 2/1000ths of an electron per cubic centimetre. Outside, it read closer to 800ths, 40 times thicker. Think about that direction for a second. We assumed the outside was emptier. It was not. It was crowded. At the same time, the particle counters told the second half of the story. The Sun's own output, the low-energy stuff streaming outward, collapsed towards zero. And the galactic cosmic rays, the shredded nuclei of stars that died before our Sun existed, jumped. Not gradually, in steps. Then they held at the higher level and never came back down. That is a door closing behind you. Whatever had been absorbing that radiation for 35 years was now on the other side of the spacecraft. And then the anomaly that turned a milestone into an argument. Every serious model of the boundary predicted the same thing. Cross it, and the magnetic field should swing. The Sun's field spirals. The galaxy's field runs its own way. The angle between them was supposed to be the signature, the stamp on the passport. Voyager 1's magnetometer watched for it. The direction barely moved. Some researchers spent the next year insisting the spacecraft had not actually left. Sit with that. We built the most successful deep space mission in history, sent it to the edge of the Sun's influence, and when it arrived, we could not agree on whether it had. Before I go further, I want to know where you are watching this from and what time it is where you are. Drop it below. And answer one thing honestly while you are down there. Do you think we are protected out here, or do you think we have been lucky? Hold on to whichever answer you gave. I want you to check it again at the end. Because here is the claim this entire story rests on, and I'm going to state it now rather than save it. Voyager 1 did not discover something terrifying in interstellar space. There is no object out there, no signal, no structure, no intelligence. What Voyager 1 did was measure from the outside for the first and only time the thing that has been standing between the galaxy and your body since the day you were born. And the measurements say that thing is thinner, leakier, and more dependent on where the sun happens to be parked in the Milky Way than any diagram you were ever shown in school. The terrifying part is not out there. It is the wall. Let me be exact about what I am not saying, because I plan to be forceful for the next hour, and forceful without precision is just noise. I am not saying NASA lied. Nothing in this story is hidden. Almost all of it sits on public agency pages and in peer-reviewed journals. I am not saying the engineers got it wrong, because the same engineers are still flying a machine built with 1970s hardware nearly half a century past its warranty. I am not saying the mission failed. I am saying the mission succeeded and the thing it found is more uncomfortable than the way it was reported. There is one more detail from that boundary crossing, and it is the one that decides how the rest of this goes. The instrument that made those density readings is one of only 2 still switched on aboard Voyager 1 today. The others have been going dark, one at a time, on a power budget that shrinks by about 4 watts every year. We are losing the only direct measurement of our own shield, while we are still arguing about what it told us. But before any of that matters, you need to know what the official version of this story actually said. Not the headline, the wording. The official version is careful. That is the first thing to notice about it, and almost nobody does. Go and read what the agency actually publishes about these 2 spacecraft. The Voyagers are described as the only spacecraft operating outside the heliosphere. Not traveling to another star, not leaving the solar system, outside the heliosphere. That phrasing is doing precise work, and it is accurate, and it is not what anybody heard. What people heard was, "We left." What was said was, "We exited one particular structure." Those are not the same sentence. The sun's gravitational reach extends far past where Voyager is now, out into the Oort cloud, a shell of frozen debris so distant that Voyager will need something on the order of 300 years just to reach its inner edge, and roughly 30,000 years to pass through it. 30,000 years. Human beings were painting cave walls 30,000 years ago. By any gravitational definition, that spacecraft is still deep inside the sun's estate, and it will be for the entire remaining history of our species. So what did it actually leave? It left the bubble, the plasma bubble the sun inflates around itself. And that distinction, the one the agency was careful about and the coverage flattened, is the whole story. Because a gravitational boundary is just bookkeeping. A plasma boundary is a shield. Now watch how the confirmation happened, because this is where the comfortable version starts to come apart in your hands. The crossing occurred on August 25, 2012. The announcement came in September 2013, over a year later. That gap was not bureaucracy. That gap was an argument. Voyager 1 lost its dedicated plasma instrument back in 1980. It had been broken for 32 years by the time it needed to be most useful. So the team could not simply measure the density of the gas around the spacecraft and settle the question. They had to infer it. And to infer it, they needed the plasma to ring. Here is how that works. Hit a body of plasma with a shock wave, and it oscillates at a frequency set by its density. the way a struck glass sings at a pitch set by how much water is in it. Voyager's plasma wave antenna could hear that pitch. What it could not do was strike the glass. The sun struck it. In March 2012, our star threw out a coronal mass ejection. That disturbance traveled outward for 13 months, crossed 11 billion miles, and reached Voyager 1 in April 2013. The plasma around the spacecraft rang. The antenna heard a tone corresponding to a density about 40 times higher than anything it had recorded on the inside. That tone is the proof. That is the entire evidentiary basis for the sentence humanity has reached interstellar space. Let that sit for a second. We confirmed the most significant boundary crossing in the history of exploration because the sun happened to burp at the right moment in the right direction 13 months earlier. If that eruption had gone another way, we would still be arguing. We might be arguing now. This is the first reversal, and I want to name it plainly because it repeats for the rest of this story in different costumes. What looked like capability was luck. Not incompetence, not fakery, not a cover-up. Luck. A working instrument would have answered the question in an afternoon. We did not have one. We had a broken sensor, a patient team, and a well-timed solar eruption. And even with that tone in hand, the disagreement did not end, because the magnetic field still had not turned. Some of the mission's own senior scientists kept publishing the case that Voyager remained inside a transitional region, a kind of magnetic corridor where solar field lines connected outward and let particles run in and out. They called it the magnetic highway. The name sounds like a triumph. Read it again. A highway is not a wall. A highway is an opening. So the reassuring frame, the one that says we crossed a clean edge and now we know where the edge is, only holds if you set two facts aside: that the confirming measurement arrived by chance and that the field data still argued the other way. I want to be fair here, and being fair costs me nothing, because the fair version is still the harder one. The consensus today is genuine and well-founded. Voyager 1 is outside the heliopause. That is not a fringe position, it is the mainstream reading, and Voyager 2's crossing 6 years later supported it. I am not telling you the scientists were wrong. I am telling you what it took to become right, and how thin the evidence was, and how much of it depended on a single functioning antenna and a lucky shockwave. Now think about what that implies for the boundary itself. If the field does not rotate the way every model demanded, then either the models were wrong about the galaxy's field, or wrong about the shape of our bubble, or wrong about how the two of them meet. Probably all three, at least a little. And each of those errors points the same direction. The edge of our protection is less structured, less predictable, and less understood than the diagram with the neat blue oval and the tidy arrows. You were shown that oval in school. I was too. It is not a lie. It is a cartoon of something that behaves more like a coastline in a storm. And here is the part that should bother you. Every statement in this chapter is about a boundary we have visited exactly twice, with two machines built before the first personal computer shipped, one of which had already lost the instrument designed for the job. That is the state of our knowledge about the outer wall of the only place we can live. So before we go any further out, we have to go inward. You cannot understand why a leaky boundary matters until you understand what the bubble is actually made of, what it is holding back, and what it has been doing above your head, every second for your entire life. Start with the sun, but not the part you can see. The sun is not just a light source, it is a leak. Its outer atmosphere is so hot that its own gravity cannot hold it, and so it boils off continuously into space, in every direction at once. About 1.5 million tons of it per second. That is a mountain of matter, every second gone. And it has been doing this for 4.5 billion years without a pause. That escaping material is the solar wind. It moves at somewhere between 400 and 800 kilometers per second, which, at the top end, is close to 1.6 million kilometers an hour. Take the distance from here to the Moon, the gap that took Apollo 3 days to cross. The solar wind covers it in about 15 minutes. It is doing that right now, above your head, at this exact moment, and it has never once stopped in your lifetime. Now, what happens to a wind that never stops blowing outward into a galaxy that is pushing back? It carves out a cavity, a bubble of solar material held open by pressure alone, inflated against the interstellar medium that surrounds it. That bubble is the heliosphere, and every planet, every moon, every asteroid, every human being who has ever lived has spent their entire existence inside it. You have never been outside it. Nothing born on Earth ever has. The bubble has structure, and the structure matters. Go outward from the sun, and for a long while the wind is supersonic, screaming outward unimpeded. Then, somewhere around 80 to 90 astronomical units out, it slams into the pressure of the surrounding galaxy and abruptly slows. That deceleration front is called the termination shock. Voyager 1 crossed it in December 2004. Voyager 2 crossed it in August 2007. And here is a detail worth holding on to. They crossed it at noticeably different distances, on different sides. The shock is not a sphere. It moves. It breathes with the sun's activity cycle. Past that shock, the wind is slower, hotter, turbulent. That region is the heliosheath, and it is thick. Tens of astronomical units of churned, compressed, heated plasma. Then, finally, the heliopause, where solar pressure and galactic pressure balance and the sun stops being in charge. That is the wall Voyager fell out of in 2012. Now the question that actually matters. What is that structure holding back? Galactic cosmic rays. Not rays at all, despite the name. They are the bare nuclei of atoms, stripped of every electron, accelerated by supernovae and other violence to speeds so close to light that they carry energies no accelerator on Earth can match. Some of them are single protons, some are ion nuclei, 26 protons riding as one projectile, arriving at nearly light speed. They come from everywhere. They have been traveling for millions of years, and the galaxy is full of them. The heliosphere fights them. The tangled magnetic field carried outward in the solar wind acts as a scattering medium, deflecting and slowing incoming charged particles, turning many of them away entirely. Physicists call this modulation, which is a very polite word for what it does. It removes a large fraction of the lower energy galactic cosmic rays before they ever get near Earth. We know it works because Voyager measured the difference. When the spacecraft crossed the heliopause, cosmic ray counts stepped up sharply and stayed up. That step is the shield, quantified. That is what the bubble had been doing for 35 years. And the bubble is only the first layer. Inside it sits Earth's magnetic field, generated by molten iron circulating in the planet's core, deflecting most of the charged particles that get through. Inside that sits the atmosphere. In radiation terms, the air above you is worth roughly 1,000 grams per square centimeter of shielding, which is about the same protection you would get standing under 10 meters of water. So here is where you actually live. At the bottom of a 10-meter water column, inside a magnetic cocoon generated by liquid metal, inside a plasma bubble inflated by a star that loses a mountain per second to keep it open. 3 shells. You cannot see any of them. You did not build any of them. Not one of them was designed. They are byproducts of physics that happened to arrange itself this way. And every organism in the history of this planet has evolved underneath all three without any of them being guaranteed. Let that sit. We talk about space as a place with hazards in it. That is backwards. Space is the default condition of this galaxy. Radiation-soaked, dense with cosmic rays, unfiltered. The protected pocket is the exception. It is a local anomaly maintained by pressure, and pressure is a thing that can change. Which brings us to what Voyager was supposed to do. The mission had a clean expectation. Fly out, find the wall, measure it, characterize it, understand how our bubble terminates. The magnetic field would rotate to the galactic direction. The plasma would thin out. The boundary would resolve into something crisp enough to put in a textbook, and we would finally know the shape of the thing we live inside. That is not what came back. The field did not turn. The plasma got denser instead of thinner. The boundary produced arguments instead of answers. And the more closely researchers looked at those two crossings, the less the data resembled a wall at all. I am not saying the shield does not work. It clearly works. You are alive, and the isotopes in your body are evidence that it has been working for a very long time. What I am saying is that Voyager was sent to find out how our protection ends, and what it found was that our protection does not end the way protection is supposed to end. It does not stop. It frays. A wall does one thing. It holds a shape and it says no. What Voyager found does neither. And the evidence for that arrived twice, from two spacecraft, 6 years apart, on opposite sides of the Sun. Start with the second crossing, because it is the one that broke the picture. Voyager 2 passed through the heliopause on November 5, 2018, at about 119 astronomical units. Voyager 1 had crossed at roughly 122. Different distances, different directions, 6 years apart, and both spacecraft found something the models had not put there. Voyager 2 still had a working plasma instrument. That is the crucial difference, and it is why its crossing is scientifically richer than the famous one. It could measure the gas directly, instead of waiting for the Sun to ring it. And what it measured, in the region just inside the boundary, was a layer where interstellar material was already present. Not outside, inside. Galactic plasma had worked its way in, past the supposed edge. Then it crossed, and on the far side, it found solar particles still leaking out. Material from our Sun, beyond our Sun's boundary, streaming away in narrow channels. Both directions, simultaneously. That is not a wall. That is a membrane. Something is getting through, both ways, at the exact location where the model said nothing should. Now go back to Voyager 1 and read its data with that in mind. The magnetic field that refused to turn suddenly makes more sense, and the sense it makes is worse. If solar field lines are threading outward past the boundary, connecting to the interstellar field rather than terminating against it, then you would expect exactly what Voyager 1 saw. A field direction that barely changes, because the two fields are joined. The boundary is not a barrier between two magnetic domains, it is a place where they splice, and the field strength out there is high. Voyager 1's magnetometer measured the interstellar field consistently above 0.4 nanotesla, meaningfully stronger than what was expected and stronger than the field it left behind. That number is small in absolute terms, thousands of times weaker than the field around a fridge magnet, but that is not the comparison that matters. What matters is that the galaxy is pressing on our bubble harder than we thought. Then there is the texture of the outside itself. In 2021, researchers working with Voyager 1's plasma wave data found something nobody had planned for. A faint, persistent tone in the instrument's output, sitting just above the noise floor. Not a shock wave, not an event, a continuous hum, always there, the plasma of interstellar space ringing quietly at its own frequency, without needing the sun to strike it. The scientific value of that was immediate. It meant density could be tracked continuously instead of in lucky snapshots. But look at what the continuous record showed. The density outside is not uniform. It fluctuates. It is turbulent on scales down to fractions of an astronomical unit. And across the range Voyager has covered, it trends upward with distance rather than settling. Stop there, because that is the inversion I want you to feel. You go outside the shield expecting the outside to be empty and calm. It is neither. It is denser than the inside, it is structured, it is turbulent, and it gets thicker the further out you go. We were the thin, quiet place. The galaxy is the crowded one. So the diagram is wrong in a specific way. Not the blue oval, exactly, the line around it. That line should not be a line. It should be drawn the way you would draw a coastline in a storm. A churning, layered, permeable zone where two systems argue with each other continuously and neither one fully wins. Let me say clearly what I am not claiming, because this is the chapter where a careless narrator would overreach. I am not saying the heliosphere is failing. It is not. I am not saying radiation is currently leaking through to Earth at dangerous levels, because it is not, and anyone telling you otherwise is selling something. I am not saying the models were built by fools. Those models were the best available reasoning from remote observation, and the entire reason we know they were incomplete is that the same scientific community built two machines, flew them for 4 decades, and published the results that embarrassed their own predictions. That is science working exactly as it should. What I am saying is narrower and harder to dismiss. The structure protecting this planet is not rigid. It is a pressure balance. And a pressure balance has a property that a wall does not. A wall's strength is a property of the wall. A membrane's position is a negotiation with whatever is pushing on the other side. Think about what that means practically. The termination shock moved between Voyager 1's crossing and Voyager 2's. The heliosphere breathes with the 11-year solar cycle, expanding when the sun is active, contracting when it is quiet. The shield is not a fixed object we sit inside. It is a dynamic equilibrium between how hard our star is blowing and how hard the surrounding galaxy is pressing back. Which means the size and strength of your protection is set by 2 variables. One of them is the sun, and the sun is variable but bounded. The other one is the neighborhood. And here is the question that should be forming right now, the one this chapter exists to hand you. What is the neighborhood actually like? We have measured about 30 astronomical units of it, with 2 aging spacecraft in 2 directions over roughly a decade. That is the entire sample. Everything we claim to know about the environment our shield is negotiating with comes from that. And the moment you look closely at that sample, the numbers stop behaving. Here is the intuition I need to break, and I need to break it before anything else in this story can land properly. You assume the outside is more of the same. Further out means emptier, colder, quieter, more uniform. Space gets more like space the deeper you go into it. It is the most natural assumption in the world, and almost nothing about the Voyager data supports it. Start with what we actually have: 2 spacecraft. Voyager 1 crossed at about 122 astronomical units and has been traveling outward ever since. Voyager 2 crossed at about 119 in a different direction. Between them, they have sampled something on the order of 30 astronomical units of interstellar space, and only along 2 thin lines. 30 astronomical units. Let me translate that, because raw units are where people disengage. 30 astronomical units is roughly the distance from the Sun to Neptune. It is a substantial number in solar system terms. Now measure it against the thing it is supposed to represent. The nearest star system is about 268,000 astronomical units away. The local interstellar cloud that our Sun is currently passing through is roughly 30 light-years across, which is something like 2 million astronomical units. So our total direct sample of the interstellar medium covers about 15,000ths of 1% of the cloud we are inside. Now the comparison, because the number alone will slide off. Imagine deciding the climate of the entire Earth from 2 thermometers, both in the same country, one in a city, one in the suburbs of the same city, reading for a decade, and then publishing a global forecast. Nobody would accept that. In heliophysics, that is the data set. I want to be precise, because this is where I could cheat, and I am not going to. We know a great deal about the interstellar medium from other methods. Pulsar dispersion measurements map electron density across thousands of light years. Absorption line spectroscopy against background stars tells us about composition and velocity. Missions like IBEX map the boundary indirectly by detecting neutral atoms that bounce back inward. The remote picture is real, and it is good. But remote sensing and in-situ measurement are different categories of knowledge, and the Voyagers demonstrated exactly how different. The remote picture predicted a field rotation. There was none. The remote picture predicted thinning density. It thickened. The remote picture predicted a boundary. We got a negotiation. Every time we have gone from inference to direct measurement out there, the direct measurement has been the surprise. Now, the part that actually breaks the linear intuition. The density Voyager 1 measures has been climbing as it moves outward, not holding steady, climbing. And on top of that trend, it fluctuates on scales smaller than an astronomical unit, which means the medium is structured at scales we cannot resolve from here and cannot predict. Think about what that does to extrapolation. If the outside were smooth, 2 data points would be worth something. You could draw a line through them and trust it. But a turbulent, structured medium with a density gradient is precisely the kind of system where 2 samples tell you almost nothing about the third place you might look. This is the scale rupture, and it is not a matter of degree, it is a change of category. A larger version of what we have done is not a better version of it. Sending a third probe on a third trajectory does not triple our knowledge. It gives us one more thread through a volume so large that threads are the wrong tool. And the practical situation is worse than that, because there is no third probe. New Horizons is still inside the heliosphere and will run out of power long before it approaches the boundary. Nothing else is on a trajectory to get there. Nothing is being built. So consider what the phrase "we have explored interstellar space" actually covers. We have taken 2 soil samples of a continent. We took them with instruments designed during the Ford administration. One of the 2 had already lost its plasma sensor before it arrived. And we are now describing the properties of a region larger than our entire solar system by a factor of tens of thousands on that basis. I am not saying the science is bad. The science is superb, and the scientists doing it are more aware of these limits than any commentator, because they are the ones writing the error bars. I am not saying we know nothing. We know more than we did, and everything we learned came from those 2 machines. I am saying that our confidence about the environment outside our shield vastly exceeds our sampling of it, and that the little we have sampled has already contradicted the models twice. And now scale it forward, because this is where it stops being an abstraction about measurement and starts being about pressure. If the local medium is that variable at scales of less than an astronomical unit, over the span of a decade, then the pressure pushing on our bubble is not a constant. It is a local condition. And local conditions change when you move, and the Sun is moving at about 25 kilometers per second relative to the material around it, dragging every one of us through a galaxy whose contents we have sampled along 2 lines. Hold that thought. Do not let it go, because Chapter 9 is going to hand it back to you with a date attached. But before the neighborhood, before the history, there is a nearer question, a more physical one. If that shield thins, or if a human being goes beyond it, what actually happens to a body? We have data on that, and the biology is worse than the engineering. Start with what astronauts see when they close their eyes. Buzz Aldrin reported it first on the way to the moon. Flashes of light behind closed eyelids, points, streaks, occasional bursts. Every Apollo crew after him described the same thing. Skylab crews reported it. ISS crews still report it today. For decades, it was studied as a curiosity, and the explanation turned out to be simple and unpleasant. Those are heavy nuclei passing through the eye. A single atomic nucleus, stripped bare, moving at close to the speed of light, punching through the retina and triggering the photoreceptors on its way past. The astronaut is not seeing light. The astronaut is seeing the track of a particle that will exit through the back of their skull microseconds later. That is what radiation looks like from the inside of a human being. And every one of those crews was still inside Earth's magnetic field, or barely outside it, for days. Now think about what Voyager measured. Cosmic ray flux stepped up sharply when it crossed the heliopause and stayed there. That step is not an abstraction about particle counts. It is the difference between the environment those astronauts were in and the environment outside our bubble. We have a direct measurement of what the shield is worth, and it is worth a substantial fraction of the galaxy's radiation being deflected before it reaches anything alive. Here is why this particular hazard is different from every other hazard in spaceflight, and why I called it a ceiling rather than a problem. Most dangers in space can be engineered away. Vacuum, solve it with pressure vessels. Temperature, solve it with insulation and radiators. Micrometeoroids, solve it with layered shielding. Even solar particle events, the bursts our own star throws out, can largely be handled by putting mass between the crew and the sun, because those particles are comparatively low energy and mass stops them. Galactic cosmic rays do not work that way. An iron nucleus arriving at nearly light speed carries so much energy that a shield does not stop it. It shatters it. The nucleus strikes an aluminium atom in the hull, and the collision produces a spray of secondary particles, neutrons and fragments, and lighter nuclei, which continue inward. In some configurations, adding shielding increases the dose inside the vehicle, because you have converted one fast particle into a shower of many. Read that again. The intuitive solution makes it worse. There are materials that behave better. Hydrogen-rich substances fragment the incoming nuclei less destructively, which is why polyethylene and water are studied as shielding. But the mass required is brutal. To meaningfully reduce galactic cosmic ray dose, you are talking about meters of water, tons upon tons of it, wrapped around the habitable volume. And every kilogram has to be lifted out of Earth's gravity well at enormous cost. The atmosphere above your head does this job for free. 10 meters of water equivalent permanently over the entire planet at no charge since before there were eyes to be struck by anything. Now the numbers, and I will keep them honest. NASA's own measurements from the Mars Science Laboratory's cruise to Mars gave a dose rate in deep space of roughly 1.8 millisieverts per day. A typical person on Earth receives somewhere between 2 and 3 millisieverts per year from natural background. So a day out there is roughly what a year is down here. Extend that. A round trip to Mars, with the transit and the surface stay, lands somewhere around a sievert of accumulated dose, depending on trajectory and solar conditions. That is not immediately lethal. Nothing dramatic happens. What it does is add a meaningful increment to lifetime cancer risk. And it is enough that space agencies have had to write career exposure limits and then argue about whether those limits permit the mission at all. And that is inside the heliosphere, protected by the very bubble we have been discussing on a trip of a couple of years. Here is the part that should bother you. That dose was measured in the shielded interior of a spacecraft inside the sun's protective bubble during a period when solar activity was actively suppressing cosmic ray flux. Every one of those conditions was favorable. That number is the good case. Now the historical comparison, and this one functions as evidence rather than color. In August 1972, between the Apollo 16 and Apollo 17 missions, the Sun produced one of the most intense solar particle events of the space age. The radiation levels in interplanetary space during that storm would have been serious for a crew in transit, potentially causing acute radiation sickness, plausibly worse for anyone caught outside a vehicle on the lunar surface. Apollo 16 splashed down in April. Apollo 17 launched in December. The storm arrived in the gap. We did not solve that problem. We did not detect it coming and reschedule. Nobody made a decision. The calendar happened to have a hole in it, and the storm happened to fall into the hole. That is the entire mechanism by which the Apollo program avoided its worst plausible day, and it is the same mechanism that gave us the shock wave that confirmed Voyager's crossing. Twice now in this story, the thing that saved us was timing. So translate all of this back to bodies, not to mission planning documents, to the actual physical situation. Every human being who has ever lived has done so at the bottom of a shielding stack they did not build and cannot replace. And the outermost layer of that stack is a plasma bubble whose boundary we have now measured and found to be permeable, variable, and pressure dependent. And the single instrument still telling us what that outermost layer is doing is running out of electricity. Voyager 1 has 2 working science instruments left. 2 out of 10. The magnetometer, which reads magnetic field, and the plasma wave subsystem, the antenna that hears the interstellar hum and gives us density. That is the entire remaining sensory apparatus of humanity's only outpost beyond the heliosphere. Here is how it got there, and the mechanism is more unsettling than a failure would have been, because nothing failed. Both Voyagers are powered by radioisotope thermoelectric generators, which convert heat from decaying plutonium-238 into electricity. Plutonium-238 has a half-life of about 87.7 years, so the fuel weakens on a schedule you can calculate. On top of that, the thermocouples that turn heat into current degrade with time. Together, those two effects cost each spacecraft about 4 watts of electrical power per year. 4 watts. A modern LED bulb draws more than that. That is the annual budget cut, and it is non-negotiable, and it has been arriving every year since 1977. At launch, the generators produced roughly 470 watts. Today, the available power is a fraction of that, and every watt is contested. So the mission has been running a triage protocol for decades. Instruments are switched off in a predetermined order, one at a time, each shutdown buying a little more life for what remains. Voyager 1's cameras went off in 1990 after the last photograph. Its plasma science instrument was already degraded and off by 2007. The ultraviolet spectrometer went in 2016. The cosmic ray subsystem was shut down in February 2025. The low-energy charged particles experiment, which had run almost continuously since 1977, was switched off on April 17, 2026, after an unexpected power drop during a routine roll maneuver in late February forced the decision earlier than planned. That leaves the magnetometer and the plasma wave subsystem. NASA expects roughly a year of operation in that configuration, and there is a constraint underneath all of this that makes it worse. The engineers cannot simply switch everything off to conserve power, because the spacecraft has to stay warm. If the hydrazine fuel lines drop below freezing, the thrusters stop working, The antenna stops pointing at Earth, and the mission ends immediately and permanently. So every power decision is a balance between keeping instruments alive and keeping the plumbing from freezing. They are managing a nearly 50-year-old machine's body temperature from 11 billion miles away. Now translate the shutdown list into what it actually means. The cosmic ray subsystem measured galactic cosmic ray flux. That is the instrument that told us what the shield is worth. It is off. The low-energy charged particles instrument measured the particle environment across the boundary. It is off. We turned off the sensors that quantify the radiation environment outside our bubble because we could not afford to run them. Not because the science was finished, because of watts. There is a rescue attempt underway. The team has been developing a power reconfiguration they nicknamed the Big Bang, which swaps a set of powered devices at once, turning some things off and replacing them with lower power alternatives to keep the spacecraft warm enough to keep working. They plan to test it on Voyager 2 first, which has slightly more margin and sits closer to Earth, making it the safer subject. Closer being a relative term. Voyager 2 is billions of miles away, and the machine they are working on has already been showing its age in other ways. In late 2023, one of Voyager 1's onboard computers began returning telemetry that was structurally intact but scientifically meaningless, a repeating pattern of nonsense. The cause was traced to a single failed memory chip. The team wrote a fix that redistributed the affected code to other locations in memory and uplinked it, and the spacecraft recovered in 2024. That repair took months, and every diagnostic step in it involved a round trip of nearly 2 days. Separately, the thrusters that keep the antenna pointed at Earth have been slowly clogging. Silicon dioxide, shed from a rubber diaphragm in the fuel system, accumulates in the propellant lines. The team has been rotating between thruster sets to manage it. There is no cleaning procedure. There is only rationing. Now the number I want you to hold. In November 2026, Voyager 1 will be 1 light day from Earth. A signal will take a full 24 hours to reach it. Translate that into how the work actually happens. You send a command in the morning. It arrives tomorrow morning. The spacecraft responds. You learn what happened the morning after that. 2 days, minimum, for 1 question and 1 answer. If the answer is bad, the situation you are reacting to is already 2 days old. If something goes seriously wrong, it went wrong yesterday, and everything you can do about it will land tomorrow. That is not communication delay as an inconvenience. That is a patient in a room you cannot enter, whose vital signs you receive on a 48-hour tape loop. And here is the part that widens this from one spacecraft's obituary into a structural problem. There is no replacement. There is no mission under construction that will fly to the heliopause and take over. There is no funded program that will produce in situ measurements of the interstellar medium after these 2 machines go quiet. An interstellar probe has been studied repeatedly in concept. It has never been built. So the honest description of our situation is this. We have one direct window onto the outer boundary of our own protection. That window was opened in 1977 by people who are largely retired or dead. It is closing on a fixed schedule, 4 watts at a time, and we have chosen not to build another one. Which raises an obvious question. If this is true, and all of it is public, why does none of it sound urgent when you read about it? Nobody is hiding anything. I want to start there, because this is the chapter where a certain kind of narrator reaches for a conspiracy, and there is not one available. Everything in the previous chapter comes from NASA's own public status pages, its own mission blog, its own press releases. The agency published the shutdowns, it published the power figures, it published the memory chip failure and the fix. There is no leak here. There is a reading problem. The softening does not happen in what is said. It happens in what gets emphasized, and who does the emphasizing, and what a headline can carry. Look at the two available framings of the same spacecraft. Framing 1. Humanity's farthest object. Nearly 50 years of continuous flight. About to become one full light day from Earth, a boundary no machine has ever crossed. Carrying a golden record with whale song, greetings in 55 languages, and a diagram of where we live, into a galaxy it will drift through for billions of years. Framing 2. A mission with 2 of 10 instruments remaining, losing 4 watts a year, whose radiation sensors have been switched off to keep the fuel lines from freezing, with no successor funded or planned. Both are completely accurate. Both describe the same object on the same day. One of them gets written about. That is not a lie. That is a selection, and the selection runs the same direction every time. Consider the incentives honestly, because they are not sinister, and that is exactly why they are effective. A space agency operates on annual appropriations decided by legislators who are not heliophysicists, and whose constituents are not either. Milestones are legible. Distance records are legible. A photograph of Earth as a pale dot is legible. The sentence, "Our only in situ measurement of the outer heliosphere is being lost on a power curve," requires 4 sentences of setup before anyone can even evaluate it. Under those conditions, the milestone framing is not chosen because it is misleading. It is chosen because it survives the trip to the audience. Journalism runs the same filter, harder. A light day milestone is a story with a date on it. A slow degradation of measurement capability has no date, no event, no photograph. It never becomes news because news requires something to have happened, and the defining quality of this problem is that nothing happens. It just continues. And then there is us, the audience. Voyager occupies a specific place in the public imagination that has almost nothing to do with its instruments. It is a symbol before it is a machine. It carries the record. It took the family portrait. It is the closest thing secular culture has to a message in a bottle, and symbols do not have power budgets. When someone says Voyager is still going, what they mean, and what people hear, is that something noble is still out there, unbothered. The machine's actual clinical status is a category of information the symbol repels. I am not claiming NASA lied. It did not. I am not claiming journalists are corrupt. They are working within a format. I am not claiming the public is stupid. The public is receiving exactly what a milestone-shaped communication system produces. What I am claiming is narrower, and I think harder to argue with. The comforting version of this story and the accurate version of this story are built from the same facts, and the comforting one wins by default every single time, without anybody deciding that it should. A doctor who tells you only your good test results has not lied to you. Every number they read aloud was real. You still walk out of that office with a wrong picture of your own body, and nobody in the room committed a wrong. Now notice the same pattern operating one level up, on the science itself. Read the careful institutional language about the 2012 crossing. The Voyagers are described as the only spacecraft operating outside the heliosphere. Precise, modest, correct. What traveled through the culture was left the solar system, a phrase that suggests a completed journey with an arrival at the other end. The agency's own caution about the gravitational boundary, the 30,000-year passage through the Oort cloud still ahead, does not fit in a headline, and so it does not go. Or read how the heliopause is drawn. That clean blue oval with the tidy arrows. It is in every textbook, and it is not a deception. It is a simplification, and simplifications have to choose what to lose. What it loses is the leakage, the turbulence, the layer where interstellar plasma sits inside the supposed boundary, the field that never turned. It loses everything that makes the structure feel provisional rather than architectural. And this is where the softening stops being merely a communication problem and becomes a practical one. Funding follows perceived urgency. Perceived urgency follows narrative. If the narrative is a heroic machine sailing on into the dark, then no reasonable person concludes we urgently need a successor mission. The story of Voyager as triumph is quietly incompatible with the argument that Voyager needs replacing. So the reason there is no interstellar probe under construction is not that scientists have not proposed one. They have, repeatedly, for decades. It is that the public understanding of what we already have is too optimistic to support the case that we need more. The framing is not just describing the situation, it is helping to produce it. And now I want to hand you the fact that reorganizes everything in this story. Because up to this point, you could reasonably file all of it under interesting, unfortunate, not urgent. The shield we have been discussing, the one that is permeable and pressure-dependent and measured by two dying machines, has come down before. There is physical evidence, there is a date, and it is in the ice. In 2024, a team led by the astrophysicist Merav Ofer published a paper in Nature Astronomy that reframes everything you have heard so far. And it does not depend on Voyager at all. Here is the setup. The Sun is not stationary. It orbits the galactic center, and relative to the material immediately around it, it is moving at roughly 25 kilometers per second. Over 2 million years, that adds up to a displacement of tens of light years. The Sun has been somewhere else, repeatedly, and the somewhere else was not necessarily empty. The interstellar medium is not uniform. It has structure at every scale: hot, rarefied regions, warm clouds, and cold, dense clouds of neutral hydrogen, thousands of times denser than the material we are passing through now. One such structure, the local ribbon of cold clouds, stretches across a huge arc of our sky. Ofer's team ran the clock backwards. They modeled the Sun's position 2 million years ago, modeled the motion of that ribbon, and asked whether the two paths intersected. They found that one portion of it, which they named the local links of cold clouds, could have collided with the heliosphere. Now remember what the heliosphere is: not a wall, a pressure balance. Our star's wind pushing out, the surrounding medium pushing in, and a boundary sitting wherever those two forces reach equilibrium. Increase the outside pressure by orders of magnitude, and the boundary does not hold its position. It cannot. It moves inward, because that is what a pressure balance does. The modeling indicates the compression could have been severe enough to push the heliopause inside Earth's orbit, which means Earth would have been on the outside, not shielded, not partially shielded, directly exposed to the interstellar medium, with only its own magnetic field and atmosphere remaining. 2 layers of the 3. For a period, the paper puts somewhere between a few hundred years and 1 million years, depending on the size of the cloud. Now the part that turns a model into evidence. Iron-60 is a radioactive isotope produced in supernovae. It has a half-life of about 2.6 million years, which means any Iron-60 present when Earth formed decayed away long ago. Any that we find now arrived recently, from outside. Plutonium-244 works the same way. Both isotopes show up in deep ocean sediments, in lunar samples, in Antarctic snow and ice, and the deposition peaks cluster around a window roughly 2 to 3 million years ago. Something delivered supernova debris to this planet's surface, globally, in that window. Under normal conditions, the heliosphere filters most of that material out before it can reach us. The compression scenario explains how it got through. And the timing lines up with something else. That same window sits at the onset of a significant cooling phase in Earth's climate history. And the researchers note the increased flux of cosmic rays and neutral hydrogen that exposure would have brought. Now, let me be scrupulous, because this is the chapter where overreach would cost me everything. The paper gives a probability. The authors calculate at least a 1.3% chance that the heliosphere encountered that portion of the ribbon 2 million years ago. 1.3%. I am saying that out loud rather than burying it, because a narrator who hides that number does not deserve to be believed about anything else. The climate link is a correlation, and the authors present it as one. It is not established that a heliospheric collapse caused the cooling. Other mechanisms for that cooling are well studied and remain viable. Other explanations for the iron-60 deposits exist, including a nearby supernova whose debris reached us without any compression at all. So take the conservative reading. Take the lowest defensible version. The lowest defensible version is still this. The heliosphere's size is set by external pressure. That pressure varies with the Sun's galactic position, and the Sun has moved and will keep moving. Whether or not the link's encounter happened as modeled, the mechanism is not speculative. It is the same physics that makes the boundary breathe with the 11-year solar cycle scaled up. The shield is not a property of the solar system. It is a property of the solar system's current address. And here is where I want you to feel it, rather than file it. 2 million years ago, there were hominins on this planet. Homo habilis, early Homo erectus. Walking upright, making tools, raising children, alive in East Africa across exactly the window when those isotopes were falling. Whatever happened, something walked through it. Not a civilization, not anyone who could record it, but ancestors, with bodies not enormously different from yours, living through a period when the outermost layer of their protection may have been somewhere behind them. That is not a thought experiment about the far future. That is family history. I am not saying we are heading into another cloud. There is no evidence of an imminent encounter, and I am not going to manufacture one. I am not saying the heliosphere is unstable on human timescales. On your lifetime, it is effectively fixed. I am saying the category has changed. For 8 chapters, this was a story about a spacecraft and a boundary. It is not. It is a story about the fact that the habitability of this planet has a dependency nobody knew to list, that the dependency is on our position in the galaxy, and that our position in the galaxy is not something we control, monitor closely, or can do anything about. Which leaves exactly one question worth asking. If our shield varies with an external condition we cannot control, how carefully are we watching it? You already know the answer. 2 instruments, 4 watts a year, nothing being built. So let me put the case together, because a verdict is not a summary. It is what the evidence forces you to conclude when you stop looking away from any part of it. 1. The boundary is not what we drew. Voyager 1 found a magnetic field that never turned. Voyager 2 found interstellar plasma already inside the supposed edge, and solar material still leaking out beyond it. Both directions, at once, at the exact location where the model said nothing should pass. The wall in the textbook is a membrane in the data. 2. We have 2 samples, roughly 30 astronomical units, along 2 thin lines, taken by machines designed before the first personal computer, one of which had already lost the instrument built for the job. Everything we claim to know about the environment our shield negotiates with comes from that. 3. The shield has plausibly come down before, and the evidence is physical. Supernova-forged isotopes with short half-lives, sitting in ocean sediment and lunar soil and Antarctic ice, clustered in a window 2 to 3 million years ago. A modelled cloud encounter that would explain how they got past a filter that normally removes them. A probability honestly stated, of at least 1.3%. Even at the low end, the mechanism is not in dispute. 4. The sensors are being switched off. Not because the science finished, because of watts. 2 instruments remain on Voyager 1 out of 10. The cosmic ray detector among the ones already dark. And the power falls by 4 every year on a schedule set by plutonium decay. 5. Nothing is being built to replace it. Any one of those on its own is a footnote. Together, they describe a situation. And the situation is that we have located the outer boundary of our own protection. Discovered it is permeable and pressure-dependent. Found evidence it has failed before, and are now losing our only means of watching it. Now let me take away the last comfortable thing, and it is a small thing that does an enormous amount of work. You think of interstellar space as a destination. Somewhere Voyager went, a frontier out past the edge, where we sent a machine and might someday send more. Reverse it. Interstellar space is the default condition of this galaxy. Cosmic ray-soaked, structured, turbulent, unfiltered. It is what almost every cubic meter of the Milky Way is like, and it is what our own location was like before the sun ignited and will be like again after it dies. The bubble is the anomaly. The quiet, thin, shielded pocket is the exception, maintained by a star burning through its fuel to keep it inflated, positioned wherever the balance of pressures currently puts it. Voyager did not leave home and go somewhere strange. Voyager left the strange place and entered the normal one, and sent back a reading of what normal looks like. Which brings me back to August 25th, 2012. Same day, same spacecraft, same numbers. Read it now with everything you have. That was not a flag being planted. Nobody arrived anywhere. What happened is that a 35-year-old machine drifted out past the last layer of the only protection this species has ever had, turned its remaining instruments around, and took a reading of the outside of the house. First time in 4 billion years of life on this planet that anything born here has measured the exterior wall from beyond it. And the reading said, "This is not a wall." Here is the sober part, and I want to be exact rather than dramatic. Nothing is happening. The heliosphere is stable. It will be stable tomorrow and next year, and for every year of your life and your children's lives. Nobody needs to do anything, and anyone telling you otherwise is not reading the same evidence I am. What changed is not the risk. What changed is the knowledge that there is a variable there at all. For all of human history, the outermost layer of our protection was not a variable, because nobody knew it existed. Then we built 2 machines and flew them for 49 years and found out it is a pressure balance with a galaxy on the other side of it. That is what Voyager confirmed. Our safety has an outside, and we have now seen it. There is genuine hope in this, and it has to come last because it only means something after the rest has landed. IMAP is flying, mapping the boundary from the inside by catching neutral atoms that bounce back. The modeling work continues, and the OFA paper exists precisely because this question is being taken seriously by people who spend careers on it. Voyager 2 still carries 3 working instruments. The power reconfiguration the team calls the Big Bang may buy both spacecraft years they were not going to get. An interstellar probe has been designed more than once by people who know exactly what it would cost and exactly what it would answer. None of that is nothing. The knowledge gap is a choice, not a law of physics, and choices can be revisited. But I want to end where the evidence ends, rather than where comfort would prefer. You asked at the start of this whether we are protected or whether we have been lucky. Look at what the record actually contains. A confirming shockwave that happened to arrive at the right moment. A solar storm that happened to fall between 2 Apollo missions. a pressure balance that happens to be favorable at our current galactic address. The shield is stable now. That is true, and it is measured, and I am not going to soften it or sharpen it. Just remember what kind of statement it is. Now is a measurement. It was never a guarantee. Voyager did not find a monster out there. It found the edge of the room, and then it started running out of light.